Hello guys, Mr. G here. Today we're going to talk about my experiment, which is how temperature affects the time for freezing water. My setup's a little funky because I'm at home, but I'll try to let you guys see everything. So my hypothesis was, what will the difference in time be from what difference in time will it be for water to freeze if I change the temperature of the water that I put in the freezer? My prediction was basically that if the water is warmer, it's going to take longer for it to freeze. Scientific content for this one. The experiment's largely about measurement, heat, and changes in temperature. Key concepts include temperature, the degree or intensity of heat present in a substance or object, especially as expressed according to a comparative scale and shown by a thermometer. Heat, the quality of being hot, high temperature. Freezing, the freezing point of water, 32 degrees Fahrenheit. Measurement, in this case, the recording of temperature using a digital thermometer, and then physical change. We also cover that a little bit in this lesson, which is usually a reversible change in the physical properties of a substance, such as water becoming frozen, which can then go back to water. In order to understand the science of this experiment, students must understand these key points. The simple action of water freezing is a process filled with science, and by learning these definitions, we more clearly understand what is happening in the experiment. That's why the scientific content part is important. The variables for this experiment, there's only two. The first one, the manipulated or independent variable, is the temperature of the water when I place it in the freezer. The responding or dependent variable is the time, or more specifically, the time it takes for the water to fully freeze. Constants and materials. The constants used in the experiment, or the things that don't change, include the temperature of the freezer and the amount of water to freeze. And I'll tell you a little story about that. I had a little bit of a hard time figuring out how much water I should do for the experiment. Started out with way too much and eventually whittled it down to 1 tablespoon was the perfect amount. It froze in a decent amount of time and I could easily see that it was frozen all the way through. So that ended up being the perfect amount. The materials that I used for this lesson include a 1 tablespoon measuring spoon, 2 to 3 small containers of water, which I use little glasses for, 1 freezer in my house, a stopwatch timer on my phone, and a digital thermometer, which again ran into some problems because I went to Walmart looking for a thermometer to use for this experiment, and a lot of them started at very high temperatures like 80 or 90. So I eventually found a digital thermometer which was able to read from very low, below freezing, all the way up to hundreds of degrees. So it ended up working perfect for this experiment. For the procedures, the way that I basically ran this experiment was I took 1 tablespoon of water. I came up with 3 measures. The first one was going to be my coldest water, which is water that I had kept in the fridge for over a day. So it was exactly the fridge temperature. That one was kept at 39.7 degrees Fahrenheit. The second one, 1 tablespoon for each trial, was water that's just sitting in my pantry. So that was the room temperature water. That one was at 75.6 degrees Fahrenheit. And then the third one, which was another one of these problems that got a little tricky, was I was microwaving water to get to the right temperature, which was 180 degrees. Unfortunately, each time that I repeated the trial for the hot water, it usually would be a little too hot. So I'd heat it up in the microwave, stir it. Oh, it's 2 degrees off. Sit there for a few minutes, wait for it to cool down. Then it could go into the freezer. Once the water is in the refrigerator, I checked about every 10 minutes, just a quick, are you frozen, are you not? This is exactly why having the bigger container of water did not work at all, because I checked every 10 minutes for like a couple hours before it was actually frozen. Even such a small amount of water, like 1 tablespoon, still was over an hour, I think, for most of the trials. And for the hotter water ended up being close to 2 hours. Obviously, as I got further in the trials, I started having some idea of when it would be frozen. I didn't need to check every 10 minutes. I could more check, okay, well, the 39.7 is usually frozen just over an hour, so I would put it in for an hour and then check it, more frequently after that. During the first run, I took several notes of what was going on, just so that I could have kind of some idea of what was going on. And depending on the temperature of the water always freezes on top first. That happened at different times, depending on how warm the water was. You start seeing where it's 3/4 of the way frozen and there's just a little bit of water left. And again, depending on the heat, it was at different times. Those steps ended up to be repeated 10 times. This experiment in particular, for me, took several days to complete. Then I took all of the data, which I wrote down, and wrote it down, and had to organize it from smallest to highest per measurement so that I could fill out the mean, median, mode, and range for that. And we'll see if my TV will work. There we go. Okay, so here's the data, which I'm not going to talk too much about, to be honest with you. For the 39.7, which was the refrigerated water, it had an average of about 75 minutes. For 75.6, the room temperature, that took about 80.4 minutes. And for the hot water, 180 degrees Fahrenheit, that took about 100 minutes. That's mean, median, mode, and range, which you can just look at on the PowerPoint. This is the bar graph that I had. So as you can see, my hypothesis was correct, with this being the colder water, and then lukewarm or room temperature water up to the hot water taking the longest time. For the results statements, I just said the water took over 20 minutes. The hot water took over 20 minutes longer than the cold water. The average time for all three was 85.2 minutes. The range from hot to cold was 25.3 minutes, difference between the cold water and the very hot water. My conclusion, or real-world applications, were that, as the data showed, hotter temperatures make for longer freezing times. The data clearly showed the warmer the water, the longer time it took to freeze. This has some serious real-world implications if we think about like global warming, where the water is getting hotter and hotter, and the amount of time you have in a year where it's cold enough for water to freeze is usually staying somewhere around the same, meaning that as the temperatures go up, there's going to be less and less ice in our world, natural occurring ice, of course, which is why you see things like the polar bears not having climates that they can live in anymore, because the world's too hot for them. Next up, I give a little description of how the experiment went from day 1 to today, which was day 9. Day 1, I basically just was discussing with the professor if this was a good experiment. Day 4, I did my first trial, or probably a couple trials, honestly, and that's where I determined that I was using way too much water, too big of a container, it was hard to do. Day 5, I decided that 1 tablespoon was the perfect way to test this experiment. I ran 3 trials for each temperature that day. Day 6, I ran 4 more for each temperature and wrote out like a rough draft of what I wanted to put for my slides in this PowerPoint. Day 7, ran the last 3 trials, organized the data by temperature, ordered the data so that it was ready for me to fill out and make my graphs and charts. Day 8, created the graphs and charts, started working on the PowerPoint, and today I finished and polished the PowerPoint as well as made this video. When I'm done talking about this, I'm going to send the video, and that's the last thing I have to do. I included some pictures from the experiment. So we've got over here the data in order so I can get my mean, median, mode, and range. Couple different pictures of where it was frozen, and then also the 3 temperatures I used for the experiment. And that's the end of it. Thank you so much.